What's up, YouTube? Evshrug here. You saw I had a little bit of extra work to do remaking my poster, but that's because I've got a lot of content that I really want to share with you. And today, that's going to be the different kinds of headphone transducers, or drivers. Let's get started with the quintessential driver, the dynamic. Now, the dynamic driver first has a permanent magnet right here. Now that sits behind the driver, and it provides the constant force that the next piece can act off of, the voice coil. Now that permanent magnet provides a force against our electromagnet, which in this case is coils and coils of copper or another type of material that when you run a current through a coil, it creates an electromagnet, and that positive or negative pulse from the amp reacts against or towards the permanent magnet, moving the cone of the driver. Now the driver cone itself is reinforced, kind of like corrugated steel or corrugated cardboard you'd find in a pizza box, but in a kind of radial pattern. So you may see drivers with like this kind of arcing pattern on it. And that is to help increase the stiffness of the driver cone. You need that part not to move. There's sometimes a misconception that the cone itself will flex in and out, but really it all moves as one piece to create that pressure and air that we hear in our ears as sound. That pressure moves our eardrum and creates sound for us. All these drivers are going to have some way of moving an element to create pressure waves in the air. Now, if we go back, around the cone is a flexible material. All right, and it's that flexible material that allows the driver cone to move towards and away from that permanent magnet, creating pressure and relieving pressure. All of sound is pressure waves in the air. Now, with a dynamic driver, the benefit of this is it's very simple, and it can be easily produced. And we've gotten so good at it that we've really refined things a lot. You will hear a great sound stage, a large amount of displacement because of how much it can move in and out. So you get a really good bass response. But the downsides of the dynamic driver is that at especially high frequencies where we have the most energy, because it's got to move faster, it's how, the displacement might be much, but because it has to change directions really fast at high frequencies, there's a better chance that that cone will not be as controlled, and you'll start to have a bit of a wobble called a modal breakup. And this will stop creating even sound pressure waves. This side may be moving up while this is moving away, and not really creating a pressure wave that we can hear as sound. So high frequencies sometimes can break up. That is one of the downsides of dynamic drivers. However, the skill and ability of manufacturers to make dynamic drivers have often been able to push that modal breakup beyond the point of human hearing, or at least most fundamental notes that we listen to in music. So you can have anything from a $10 driver, dynamic driver, all the way up to multiple thousands of dollars that sounds really good. And you can find it in earbuds, in-ear monitors, on-ear headphones, and over-ear headphones. Almost every type of headphone will have an option with a dynamic driver. Next up, we have the Planar Magnetic. Now, the entire design focus of a planar magnetic headphone is to avoid that modal distortion. Here's how it's constructed. So it's constructed of 3 layers. We have a bank of permanent magnets, and then we have the central membrane that has its complete surface area covered in wires to make it one big electromagnet. And then the back layer is also another bank of permanent magnets, usually positive and negative. So with the middle acting as an electromagnet, and able to change its polarity between positive and negative at will, you would want to have the back panels be either all positive or all negative. So that way the central wafer is attracted to one side or repulsed from the other. And you get yourself an array of magnets. And they're spaced out so that there's gaps in between them so the air can flow through. But when you have them both together, it completely covers the surface area of the central driver, so that way the force of the attraction or repulsion is spread out across the entire central membrane at once. Now that means that instead of having just a coil around the center and everything's hopefully staying balanced, you're evenly pushing on the entire surface area of the membrane. The downside of that is there's not very much room between that sandwich of magnets, so the central diaphragm can only move so much before it hits the magnets. There's also the air has to be guided in between the magnets. It's almost like a screen or a gate, so the air has to flow through, and you can't have as much excursion of the driver, which normally would reduce the amount of air displaced and the amount of base you get. So they usually make planar magnetics bigger, so that way the larger surface area, even though it can only move a little, because it's bigger, it will still push an equal or greater amount of air while not having any of that modal distortion, and creating a cleaner high end and a pretty good low end as well, because again they make it bigger to get a good bass response. Now, planar magnetic drivers used to only be found in over-ear headphones because of their sheer size. However, there's recently been some planar magnetic in-ear monitors. The drivers are still larger than your average dynamic driver or another driver we're going to talk about soon, but it works, and it's cool to have these advancements in technology. Next, we have the Electrostat. Now, an Electrostat may look to have a similar construction as the planar magnetic headphone. However, there are no permanent magnets in this one. So let's look at how this is built. So on the outside, we have these things called stators, and stators are electromagnets, but they will have just either an electrical or a negative charge presented towards the center. And then the center is another electromagnet. So this central membrane is what makes it so darn special. Different from a planar magnetic headphone that has coils and traces of wire in it to make it be an electromagnet. In this case, the membrane itself is made of a metal or some other super thin conductive material. The entire surface of it is an electromagnet, and it is usually super thin, like measured in nanometers, and so low mass, it's actually lighter than air. Now what that means for the sound is that it can recover from any move and change its position easily because it has very low inertia, and you get super fine, super precise detail in the treble especially. There's nothing sweeter than a Electrostat treble, and a just really clean, really tight sound all the way down into the lowest registers. However, like the planar magnetic, it is going to be limited to how much excursion and how much air it can move and displace because of the stators on each side of it, and also for being attached around the central edge. So usually you'll have a sense of bass in there, but it won't be that rumbling, shaking bass that you might feel with a dynamic headphone that can really move a lot of air. Now, Electrostat is most often found in a larger ear speaker type of headphone. However, it has also been found in some over ears, and they've even created a few in-ear monitors, but again, like the planar, most of the gear is outside of the ear. It's not inside the canal, it's kind of in the superstructure just outside. Now there's another cost to being the king of the sound quality heap, and that would be literally the cost. The least expensive one is a $500 system, but you can get them as expensive as $60,000 for a headphone. So it's all because of how difficult it is to manufacture that driver and all the associated amp gear that goes along with it. They don't really call them amplifiers. They actually use something called an energizer, but essentially it's high voltage power to make those stators, those kind of screen door grids on the outside, get their charge and be strong enough like a permanent magnet. And wow, yeah, so it requires a lot of power. Your electric bill would go up. They're not very portable. There is one pair of in-ears that use this, but you have to have a big pack to power it. Yeah, so power. Next up, we have the most compact driver type, the balanced armature. Now the balanced armature starts off with the box shape. Now inside this box, we have some permanent magnets and an armature that is balanced. I'll show you. Now this thin line I'm drawing represents the armature, and it is attached at one point, but it is allowed to freely move up and down. So this can move up or down, and when it does, it moves this central plate up here, and then this big fat place can move up or down, moving air inside of this tunnel, which is then pushed out as waves through the nozzle. So like an electrostat, we again have a super lightweight moving part that can receive an electrical current and become itself an electromagnet, able to be attracted and repelled by other magnetic forces. Like a planar magnetic, though, it has permanent magnets inside, which means it doesn't need as much voltage and electricity to make its moves. And also like a planar magnetic, that wide plate on top always stays level as this arm moves up and down, so you don't have any modal distortion. So the balanced armature is extremely compact and low power usage, so we can easily fit it inside of an in-ear monitor headphone. However, it doesn't displace very much air, so it doesn't create the volumes we need for the larger headphones, at least not by itself. Now that small size brings us to the disadvantages of the balanced armature. You can't move as much air, and you also can't move that arm very far. So that means that each driver is usually limited into what range of frequencies it can create, and also it just doesn't create that much displacement for those low-end notes, those bass notes where you really need to feel that impact. How you guys holding up? Oof, that's pretty long so far, isn't it? I have to admit, I personally have had to do a whole bunch of takes to get this far, and a couple days. There was a power outage, there was neighbors with power tools, just, if you've made it this far, give yourself a like, and leave a comment in here and tell me how it's going. That was all the main types of drivers. I've got two others that are a little bit more rare. We'll take a look at those next, starting with MEMS. Okay, so MEMS are really new, and I had to do my research on this a bit because essentially there haven't been that many successful, if any, successful MEMS headphones of any kind yet. MEMS stands for Microelectric Mechanical Systems. Yes, I had to look down and read that. It's not like a meme or the internet fun things of just fun sayings, but MEMS are basically like a computer chip driver, right? So it's kind of like a whole bunch of pixel-sized drivers that either look like miniature electrostat drivers, or they're using piezo electric systems where basically electric current applied to something makes it flex. And they're very, very tiny, and they're very, very efficient. They can be mass produced very cheaply and just kind of cut down to size, and you basically have a whole bunch of these little driver pixels all over a little chip, and it's very efficient to put into an in-ear headphone, for example, but being super, super tiny little driver pixels, they don't displace that much air, so there's been a lot of challenge in getting enough volume to even hear them, and also challenge in getting a wide frequency response. However, there are a couple companies like XMEMS just published something this year saying that they've managed to make a MEMS driver capable of 10 kilohertz all the way up to beyond 20 kilohertz, or maybe it was just 20 kilohertz. But wow, if that's true, we'd be talking some seriously power efficient in-ear monitors, which would be great for wireless in-ear monitors, because then your battery life would last a lot longer. And then because they're made like on a factory line, like a computer chip would be, they can sound exactly the same from one production driver to the next. So there's a lot of consistency. So that's pretty cool. We'll have to see how that develops. We'll have to see if it's able to provide some good bass response. We'll have to see if maybe they'll kind of end up replacing balanced armatures, for example. MEMS are already very commonly used in microphones on like your cell phone. They're also used in the gyroscope and the accelerometer inside your cell phone. So we'll have to see how much this can produce, and if it can overcome some of the challenges previously that have affected it to produce lower bass sounds. Okay, the last type of driver that we're going to talk about today are the bone conducting drivers. Essentially, these are not as much about moving air for the first time. They sit right on the bone outside of your ear, and then they have a little motor that kind of thumps against that bone and vibrates against that bone, causing it to vibrate through to your eardrum. And the vibrations have the same frequency as air pressure waves, and it ends up creating sound. The awesome thing about a bone conducting headphone is that it's completely not covering your ear. So by completely not covering your ear, you can hear the outside sound perfectly. You can go, bike riding or running, or pay attention to the real world while also getting maybe a communication with other people, or listening to music. But the issue and the downside of bone conducting headphones is that when it comes to music, they don't produce low frequencies very well, and they kind of sound a little bit muffled. They're better than they used to be. One thing about this headphone is that every few years I hear about it, like as if someone just invented it and it's the newest, greatest thing and it's going to change the world. But the old ones would sound like you're hearing music underwater. And now they're better, but they still travel through your real solid material, and they just can't quite carry the fidelity and the lower end response that all of these other driver types can. So that's it for all the different types of drivers. And let's have one last look now at everything I've drawn, because it took a long time. I'm Ev Shrug, and I'm still learning stuff every day, but if you want to come on this journey with me, subscribe and hit that notification bell. So this central membrane, bane of my existence. So this